Dear students, today I am going to demonstrate how to construct a bimodal curve for a 3-component system. So, essentially we are going to basically verify the phase rule, and the theory part of the phase rule already supplied to you. So, I am sure that you might have read all the procedure and also the background theory required to do this experiment. And in this video I am going to show you how to take the readings, and after taking the readings I will be posting the readings to you, so you have to do the calculation part. So, this demonstration is only for taking the readings, okay? And in this experiment, if you look at the procedure, so we have to have 3 components in this phase rule experiment. The 3 components are acetic acid, water and then chloroform. So, we have taken all these 3 component liquid components in 3 different burettes. So, this is acetic acid, this is water and then this is chloroform. So, what I am going to do is that we are going to make in this experiment as per the procedure. In this experiment we have to take different mixtures of 2 components, and for the specific composition of 2 of the components, how much is the other third component is required, that we have to estimate by titration method. Okay. So, for the sake of convenience, what I do is that, so I will just take a specific composition of acetic acid and then chloroform, and to which I normally we will add the water, and then at a certain point what we see is that there is a end point. In this case the end point is nothing but a turbidity. Okay. So, we will see as you are keep on adding the water to the 2 component system, then it becomes a turbid. So, that means that is we have reached the end point. Then once that is done, then you have to take another composition of acetic acid and then chloroform, and again you do the titration and find out how much water is required, content is required, that required quantity we can estimate by the end point. End point is turbidity. Okay. So, you know that acetic acid water does not mix very well, whereas the chloroform does not mix with the water. Okay. And then chloroform, acetic acid, again they mix well. Okay. At a larger extent this is the scenario, but then to certain extent all these at a specific composition of all these 3 actually mix each other. That is something that we are going to find out, what is the exact composition of the 3 components, and then from there we will try to construct the bimodal curve for the 3 component system. As you can see in the theory also, that for a 3 component system we have taken 3 liquids. So, let us say phase is 1, and then all the 3 are basically phase is 1, and then phase is 1 in the sense they are basically different phases, but then as you mix together at equilibrium you will see only one phase, and then components are 3, and therefore normally what we require is the total number of degrees of freedom are essentially 5. Okay. There are 5 basically the 5 degrees of freedom that are required to define this complete system. However, what we can do is that we can fix the 2 of the variables, those are the temperature and the pressure. So, we are doing at normal temperature, room temperature, and then pressure is 1 atmospheric pressure. Therefore, those things are already fixed. So, the rest is that this equilibrium basically governed by the concentration of the 3. Okay. That is something that we are actually trying to estimate for a specific composition of 2 of the liquids, how much the third one is required, we are trying to estimate. So, after collecting the data, so these data, from the data we can actually plot all these values in the equilateral triangle, and then from there we can construct the bimodal curve by which we can understand how this system is behaving. Okay. So, let us go to the demonstration part. So I will just show you in this video one particular reading, and rest of the readings basically we will do the experiment and such a data will be posted to you. And let's say what I do for the sake of convenience, I have here acetic acid. So let's say I will take a acetic acid, 10 ml of acetic acid I would be taking initially. So this is a 25 ml burette it is. So I am just trying to dispense from this approximately 10 ml of acetic acid. So as it is reaching 10, so you have to slow down the speed. So it is now 10 ml I have dispensed into this conical flask. Normal experiment you are recommended to use the dried conical flask, but however I am showing in a conical which is not properly cleaned or which has some other liquid as well. Anyway, that is not a big issue in this case because we are going to add water. So this is the chloroform and I am going to add the chloroform. Chloroform also I am going to take 10 ml of chloroform. Okay, so it is already this is a 25 ml, this is also a 25 ml burette. So again I am going to dispense 10 ml of chloroform. So I will show you that these two liquids actually nicely miscible each other, and it is a kind of nice homogeneous solution because they are nicely miscible. Okay, so I have taken 10 ml of chloroform also. You can notice here, and in the liquid doesn't have any boundary. So both the liquids, chloroform and acetic acid, both are mixed together. However, you don't see any separation. That means they are nicely miscible to each other. However, this is not the case if you start adding the water. Okay, so when you start adding the water, for a particular concentration of the water, this particular homogeneous solution becomes turbid. That means, that means certain amount of water, okay, it can accommodate this composition of chloroform and acetic acid mixture. It can accommodate water, certain amount of water, but then beyond that point that it will show you a turbidity. That is the end point that we have to determine the end point by looking at the turbidity. Okay, so I started adding. So what I do, I just add slowly because we do not know where exactly we will find the turbidity. So it is always better that you add few drops and then dispense, and you have to follow the titration experiment precautions as well. So you cannot add everything at once and then start swirling. So you have to add slowly and then shake it well, and then again you add it. So that is the way you should go on. Okay, so I'm just adding little and just observing what is the situation inside the conical. So I can still find a homogeneous solution. I don't see any haziness or the turbidity. Okay, so till I reach a turbidity, I will add. Okay, so you can notice here, I am sure that most of you would have noticed. So there is a turbidity. There is a turbidity. Earlier it is a clear solution. Now you can see there is a haziness. So this is the point that we have to consider and then record it. If I look at my burette value, this is approximately the burette value. You can note down here that this is 3, right, and then approximately 3.3 is the reading, 3.3 or 3.2 is the reading. Okay, so at water is 3.3. So this particular value is specific for the composition of acetic acid and chloroform, and if you change the composition, Initially, as you have seen that I have taken 10 ml of acetic acid and 10 ml of chloroform. Suppose if I change this composition, the amount of the third component, this is the third component, volume will be different. Okay, so that we have to experiment it, and in the experiment what you have to do is that if you come over here in the physically, this is what generally we instruct the student to collect the data. This is the way that normally you have to collect readings. You have to have few conical flasks. All these conical flasks you have to basically properly clean it and then dry it time to time. So you cannot take any wet conical flask. The way I have taken, you shouldn't take it, but so the conical flasks are basically getting it ready. Once they are done, then we will be taking readings and then we will post to you. Now after that, in each conical flask you can prepare different composition, like let's say keeping the total composition is total volume of the acetic acid and chloroform, keeping the total volume of the acetic acid and chloroform constant, the other water can be varied. Okay, and the mixture of different mixture we have to prepare approximately 12 or 13 mixtures, as you can see in the table. We have to prepare approximately 12 mixture of acetic acid and chloroform solutions, like 18.5 or 19. Okay, 19 ml of acetic acid and then 1 ml of chloroform. So the total volume is 10. So then the next composition would be 18 ml of acetic acid and chloroform will be 2 ml. So here you can see that total volume is 20 ml. So like that you have to have some variation. So approximately 12 or 13 variation that we can have it. And each conical having taken all those these composition, so one by one these conical flasks you can titrate it with the water and you estimate how much water is required for each composition of the acetic acid and chloroform, that you have to estimate, and then burette readings you have to basically measure it and then you have to record in the rough notebook. So after completing this experiment, you can actually go back and then calculate the percentage of the weight percentage of the each solvent, okay, each liquid phase that we are taking. And then from there, by looking at the percentage of compositions, so we can actually take a graph sheet wherein we can plot the bimodal curve by plotting initially equilateral triangle, and then by then we have already calculated the percentage of weight percentage of the each liquid, and these liquids, these percentage values you have to mark it in the equilateral triangle, which I would be basically explain to you once again as I explain the theory part in the later. Okay, so this is the small demonstration about the phase diagram experiment, how to construct phase diagram for a 3-component system, that is the experiment. For this we need 3 liquids, and basically we have to take different compositions of any 2 liquids. For the sake of convenience, I have assumed I have taken the chloroform and acetic acid, and the third component, how much it is required for a specific composition of the liquids, you have to estimate. That is the data collection part. Then the rest is basically the calculation part, which I will be discussing. Thank you for listening.